Alright, so on this episode of MathMeowTics, we're going to graph and we're going to talk about the key attributes of the quadratic 2x squared plus 8x. And we're going to find our axis symmetry, vertex, domain, and our range. Now, this is a happy, so that means that we have a lowest. Okay, so that means that this is going to be y greater than whatever our vertex is. So I'm going to go ahead and put my point here so that I can know that I remember that my axis symmetry is the equation x equals. And we know that my vertex is going to be a coordinate point. We know that my domain, again, is going to be all real numbers. Okay? So let's go ahead and use our handy-dandy calculator. I'm going to go to y equals. I'm going to clear it. And I'm going to put in my calculator 2x squared. And I'm going to put plus 8x. And I'm going to graph. Now I know that this is in the negative region again. So now I'm just going to go look at my tables. So second table. Let's make sure I'm going to put that at 0. Okay. So again, I want to look and see where I have the values that are duplicating. So if I notice here, I've got negative 6, negative 6. I've got 0, 0, 10, 10. So that means that those are my symmetric pairs. So my vertex is there at negative 2, negative 8. So I'm going to write my vertex, negative 2, negative 8. So that means that lets me know that my axis of symmetry is x is equal to negative 2. My range is going to be every value greater than negative 8. So I'm going to go here and plot. Uh-oh, I'm going to need to put more rooms here. Hold on. Toot. I did not mean to do that. So I need more room. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that should be good. Okay. So that is not there. Okay, hold on. I need to redo my graph. Sorry about the technical difficulties there. Okay, that should be good. So our vertex is at negative 2, negative 8. Let's make sure. Negative 2, negative 8. Yes. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. That is our vertex. And we are a happy, so that lets me know that's going to be the lowest. Now, in terms of plotting the point, this is going to be x, this is going to be y. My vertex is negative 2, negative 8. So then my next point is going to be negative 1, negative 6. So I'm going to go right 1, 2, 3, 4, 5, 6. And then my next point is going to be at 0, 0. Which that's okay. We can have that. Let me do a different color so it's easier to see. That's kind of hard to see. There we go. And it's pretty. So, and then this is my axis of symmetry. I know that my parabola is going to be going in this direction. Again, my other one's going to be on the same value here. So then it's 2 units away. So my graph is going to look like that. And there's more of a curve down there at the bottom. Now, the point that I wanted to make is normally if we were to talk about a parabola and talk about a parent function, 2, 3, 1, 2, 3, 4. Okay. Normally, if you were to talk about moving these, you would just switch with, like, if you had x squared plus 3x plus 2, you would just move it. You would shift it depending on where the vertex ends up putting it. So you would shift it. But this one, because our a value is 2, this little band here, instead of being 1, right 1, up 1, it's right 1, up 2. And then it's right 2, up 8, instead of right 2, up 4. Think about the pattern of a parent function in terms of function, each one is going to give you a perfect square. This would be 0, 0, 1, 1. This would be 2, 4. This would be 3, 9. This would be 4, 16. Okay? So that's an interesting thing to note when your a value is 2. That can also kind of make it easier for you to graph it and not have to sit here and write down every point and plug it in. But worst comes to worst, you can just go ahead and plot it and put it in your calculator. All right? See you in the next video, and that about does it for vertex